How terrifying is absolute zero? Why can the highest temperature in the universe reach a shocking 1.4 trillion degrees Celsius, while the lowest temperature is only minus 273.15 degrees Celsius? First, we need to understand what absolute zero is. In 1802, French chemist Louis-Gay-Lussac conducted an experiment based on the gas expansion effect. He prepared a beaker with volume markings and a movable piston that fit the beaker, then expelled all the air from the beaker. Then, he sealed the beaker after injecting some nitrogen gas through a hose. He used a thermometer to measure the room temperature at that moment. When the temperature was at 24.83 degrees Celsius, the gas volume in the beaker was 84 milliliters. Next, he placed the beaker in a large bucket of water and added ice to cool it down to 0 degrees. By checking the scale, he found that the gas volume in the beaker had decreased to 77 milliliters. Then, the cold water was replaced with freshly boiled wastewater. According to the measurements, when the temperature reached 99.33 degrees Celsius, the gas volume in the beaker changed to 105 milliliters. As the water temperature continued to drop, the gas volume gradually decreased as well. Now, draw a graph to analyze the data, with the horizontal axis representing temperature and the vertical axis representing gas volume. After marking these data points, we find that temperature and volume are actually in a linear relationship. Now we can infer the limit data that cannot be measured by extending this inclined line. Finally, we can see that when the temperature drops to minus 273.15 degrees Celsius, the volume of the gas becomes zero. Since the volume cannot be lower than zero, we can infer that the lowest temperature cannot be lower than minus 273.15 degrees Celsius, even if we repeat the experiment with different gases. The measurements may vary, but the temperature is still proportional to the volume. When approaching absolute zero, the movement of particles will become so slow that they are almost at rest. Everything will be frozen, even light. If we touch an object at absolute zero with our hands, we may not feel any pain at first. But the cold will quickly penetrate your skin, damaging the nerve endings in your fingertips and some muscle tissue. Unfortunately, to this day, scientists have not been able to artificially create an environment at minus 273.15 degrees Celsius. However, in the direction of the Centaurus constellation, about 5,000 light-years away from Earth, there exists a planetary nebula with a temperature of minus 272.15 degrees Celsius, which is just 1 degree above absolute zero, and is currently the coldest known place in the universe. Many scientists pessimistically believe that the end of the universe may lead to a big freeze with mysterious dark energy guiding the cosmos. Moving towards a future of cooling and stagnation, all natural activities will come to a halt. The universe will eventually evolve into a state devoid of thermodynamic free energy, and all physical laws will collapse, leading to the extinction of any form of life. In about 10 to the power of 100 years, all black holes in the universe will completely disappear. For the first time since the birth of the universe, it enters a state of eternal stasis. Time will lose all meaning, and the increase of entropy will come to a halt. The universe has finally reached the end of disorder, where nothing will happen for all eternity.